In this class, we're going to go over questions on differential calculus. We are asked to find the derivative of the following function using the first principle. Okay, let's start with the first question. Solution. We have 1 over x raised to the power of 3. Now, in an attempt to differentiate this function, just set this function equals to a letter. In this case, I'm going to use y, you understand? So, here I'm going to have y equals to 1 over x raised to the power of 3. That is, let y equals to 1 over x raised to the power of 3. Do you understand? Okay? The next step is that we are going to increase x by delta x. That means that there will also be a corresponding increment in y by delta y. You understand? Okay? So here I'm going to have y plus delta y is equals to 1 over x plus delta x raised to the power of 3. Okay? Now, having done this, the next step is that you have to expand x plus delta x raised to the power of 3. So here I'm going to have y plus delta y is equals to 1 over, okay, 1 over x. Now, if you want to expand this, you can do it in two ways. You can use Pascal triangle and you can also do normal expansion, okay? Now, using the Pascal triangle, let's quickly expand this. Using the Pascal triangle, we are going to have x raised to the power of 3, delta x raised to the power of 0, plus x raised to the power of 2, delta x raised to the power of 1, x plus x raised to the power of 1, delta x raised to the power of 0, delta raised to the power of 2, x raised to the power of 0, delta x raised to the power of 3. Okay? Now, this is the coefficient of our expansion. We're going to have 1, 3, 3, 1. So, here I'm going to have 1, 3, 3, 1. Okay? So, for this, I can write as y plus delta y plus delta y is equals to 1 all over x raised to the power of 3 plus 3x squared delta x plus 3x delta x squared listen, delta x squared plus delta x raised to the power of 3. Okay? Please kindly pay attention. The next step is that I'm going to make delta y the subject of the relation. Okay? So I'm going to have delta y is equals to 1 all over x raised to the power of 3 plus 3x squared delta x plus delta plus 3x delta x squared plus delta x raised to the power of 3. Okay? So minus y, because if this positive y crosses the equals to sign, the sign is going to change to negative. Okay? So that's how I have minus y at the right hand side of this equation. Now, don't forget that y is what? 1 over x raised to the power of 3. So I'm going to have delta y is equals to 1 all over x raised to the power of 3 plus 3x squared delta x plus 3x delta x squared plus delta x raised to the power of 3 minus 1 all over x raised to the power of 3. Okay? Now, having gotten to this point, the next step is that we have to take the LCM, okay, of both fractions. The LCM of both fractions is the LCM of this and this will be, okay, we can write it here. Delta y is equals to, now the LCM will be x raised to the power of 3 plus 3x raised to the power of 2 delta x plus 3x delta x raised to the power of 2 plus delta x raised to the power of 3 multiplied by x raised to the power of 3. Okay? The LCM will be the product of this and this. For example, let's take you want to take the LCM. Let's make this Pascal triangle. Let's say you want to take the LCM of 1 over a minus 1 over b. The LCM will be AB, you understand? Because that will be A times B, you understand? So, if you want to take the LCM of this fraction and this fraction, that will be this multiplied by this. Do you understand? Okay? Now, the product of this divided by this, that will be what? X raised to the power of 3. X raised to the power of 3 times 1, that is x raised to the power of 3 minus, open the bracket, this, the product of this divided by x raised to the power of 3, that will be what? This multiplied by 1, that is x raised to the power of 3 plus 3x raised to the power of 2 delta x plus 3x delta x raised to the power of 2 plus delta x raised to the power of 3. Okay? I'm very sure you understood how I got here. If you didn't understand, listen to the explanation again. When I got here, I take the LCM. LCM simply means taking the lowest common factor, lowest common multiple of both the denominator of both fractions. Now, to take the LCM, I take this and this, and I multiply them together. That's why I have this. Now, this divided by this, I'm left with x raised to the power of 3. X raised to the power of 3 times 1 will give me x raised to the power of 3. The product of this divided by x raised to the power of 3, I'm left with this. All this multiplied by 1 will give me this. Do you understand? Okay, now, having gotten to this point, all you have to do now is that you have to simplify it. Okay? You have to simplify. So here I'm going to have, please pay attention, delta y is equals to x raised to the power of 3, x raised to the power of 3. Now, let us simplify the numerator. Minus x raised to the power of 3 minus times plus 3x squared delta x. That will be what? Minus 3x squared delta x. Are you there? Minus times 3x delta x squared. That was minus 3x delta x squared. Okay? Minus times positive delta x raised to the power of 3. That was negative delta x raised to the power of 3. Okay? This will be all over x raised to the power of, okay? And you can open the bracket of this as well, okay? So let's open the bracket. We're going to have x raised to the power of 3 times x raised to the power of 3. That will be what? X raised to the power of 6. So I'm going to have x raised to the power of 6. X raised to the power of 3 times 3x squared delta x. That will be what? 3x raised to the power of 5 delta x plus 3x raised to the power of 5 delta x. Don't get confused, okay? It's simple. What I'm doing is that I open this bracket using this negative sign. So I arrive at this at the numerator. Now, what I'm doing next is that I want to open this bracket as well using this x raised to the power of 3. X raised to the power of 3 times x raised to the power of 3. That will give us what? X raised to the power of 6. Okay? Now, we are having the second term inside the first bracket. Multiply 3 x raised to the power of 3 by 3x squared delta x. That is 3x squared delta x multiplied by x raised to the power of 3. Now, we are having 3 x raised to the power of 2 here. That will be 3x raised to the power of 2 plus 3 delta x. Okay? That is 3x raised to the power of 5 delta x. Do you understand? That's how I got 3x raised to the power of 5 delta x. Now, x raised to the power of 3 times 3x delta x squared. That will be what? That will be plus 3x raised to the power of 4 delta x squared. Okay? Now, x raised to the power of 3 times delta x raised to the power of 3. That will be what? Plus x raised to the power of 3 delta x raised to the power of 3. Okay? Now, having arrived at this time, let us simplify the numerator. So I'm going to have delta y is equals to x raised to the power of 3 minus x raised to the power of 3. That will give us 0. Okay? So I'm left with negative delta x raised to the power of 2, negative x raised to the power of 2 delta x minus negative 3x delta x squared, negative 3x squared delta x minus 3x delta x squared minus delta x raised to the power of 3 all over, okay, x raised to the power of 6 all over x raised to the power of 6 plus 3x raised to the power of 5 delta x plus 3x raised to the power of 4 delta x raised to the power of 2 plus x raised to the power of 3 delta x raised to the power of 3. Okay? Now, I'm very sure you understood how I got to this point. Now, having gotten to this point, all you have to do now is that just divide both sides by delta x or multiply both sides by delta x. You understand? So, I'm going to have, just multiply this by delta x. That means we are going to have 1 over delta x multiplied by this, both the first side And you have to multiply this also by 1 over delta x, 1 over delta x. Okay? What I mean is that just multiply both sides by 1 over delta x. So we are going to have delta y multiplied by 1 over delta x. That is what? Delta y all over delta x. Okay? Is equals to negative 3x raised to the power of 2 delta x minus 3x delta x raised to the power of 2 minus delta x raised to the power of 3 all over x raised to the power of 6 plus 3x raised to the power of 5 delta x plus 3x raised to the power of 4 delta x raised to the power of 2 plus x raised to the power of 3 delta x raised to the power of 3 multiplied by 1 over delta x. Okay? Let's just put the bracket, okay? Let's put the bracket. Now, the meaning of this is that we multiply both sides by delta x. You understand? We've multiplied both sides by 1 over delta x. Do you understand? Now, this delta x that you see here can cancel this. This delta x can cancel this delta x. This will be this. You can cancel this as well. It's just like saying that negative 3x squared delta x all over delta x. Negative 3x delta x squared all over delta x and minus delta x raised to the power of 3 all over delta x. You understand? That is the operation that I performed here. Okay? So now negative 3x squared delta x all over delta x will give us negative 3x squared. Okay? Minus negative 3x delta x squared divided by delta x. That will give us negative 3x delta x. And then minus delta x cubed divided by delta x. That will be what? Minus delta x squared. Okay? So that is how that will be the numerator for this. Delta y over delta x is equals to negative 3x squared, negative 3x delta x minus delta x squared all over x raised to the power of 6, okay, plus 3x raised to the power of 3x raised to the power of 5, 3x raised to the power of 5 delta x plus 3x raised to the power of 4 delta x squared. Please, are you there? 3x raised to the power of 4 delta x squared plus x raised to the power of 3 delta x raised to the power of 3. Okay? Now, please, the solution is simple. Yours is just to pay attention, okay? I'm just simplifying, okay? I multiply both sides by delta x here. So I have delta y over delta x. And this delta x that you see here will have effect on the numerator. That's why I show the solution here. You understand? I bring the numerator that you see here. These are individual numerators, all divided by delta x. Each of them divided by delta x. That is how I arrive at this numerator. You understand? Do you get what I'm saying? Okay? Now the next step is that you have to limit delta x as it tends to 0. Okay? That means that in this case we are going to have dy all over dx limit delta x as delta x tends to 0. So I'm going to have delta y all over delta x will be equals to, now, do you know the meaning? That is, anywhere I see delta x in the right hand side of the equation, I'm going to replace it at 0. Okay? So in that case, I'm going to be having something like, okay, negative 3x squared, negative 3x delta x. Okay, now we are substituting 0 as delta x. So I'm going to have multiply by 0 minus 0 squared all over x raised to the power of 6 plus 3x raised to the power of 5 multiplied by 0 plus 3x raised to the power of 4 multiplied by 0 squared plus x raised to the power of 3 multiplied by 0 raised to the power of 3. Let me rewrite it so that you can see it very well. I want to rewrite it so that you can see it very well, okay? Now, x raised to the power of 6 plus 3x raised to the power of 5 multiplied by 0 plus 3x raised to the power of 4 multiplied by 0 squared plus x raised to the power of 3 multiplied by 0 raised to the power of 3. Okay? So, now let us simplify. Here, I'm very sure I can erase this. Okay, let us erase this place. So that means we are going to have dy all over dx is equals to, now, negative 3x raised to the power of 2 all over, because if you multiply negative 3x by 0, that will be 0, okay? And if you subtract 0 from any number, it also remains 0. 0 squared is 0, okay? Now, let's go to the denominator. I'm going to have x raised to the power of 6. 3x raised to the power of 5 multiplied by 0, that will be what? 0. 3x raised to the power of 4 multiplied by 0 squared, that will be what? 0. X raised to the power of 3 multiplied by 0. 0 raised to the power of 3, that is what? 0. Okay, so we are left with what? Negative 3x raised to the power of 2 all over x raised to the power of 6. Okay, now let us proceed. dy all over dx can be written as, just factorize this out. I'm going to have x raised to the power of 2 all over x raised to the power of 6. Do you understand? So we can rewrite negative 3x squared all over x raised to the power of 6 as negative 3 into bracket x raised to the power of 2 all over x raised to the power of 6. The reason why is that, because I want to express x over 2 and x raised to the power of 2 and all over x raised to the power of 6 as indices, okay? According to law of indices, if you have x raised to the power of a all over x raised to the power of b, it can be written as x raised to the power of a minus b, okay? So x raised to the power of 2 all over x raised to the power of 6 is what? X raised to the power of 2 minus 6, which is what? X raised to the power of negative 4. So in that case, I'm going to have dy all over dx is equals to negative 3x raised to the power of negative 4. So you can write it as negative 3 all over x raised to the power of 4, which is the final answer. So the derivative of 1 all over x raised to the power of 3 is negative 3 all over x raised to the power of 4 using the first principle, okay? Now, let us apply the polynomial rule or the power rule to check maybe our answer is correct. According to the polynomial rule, if y equals to 1 over x raised to the power of 3, we can rewrite y as y equals to x raised to the power of negative 3. And according to the polynomial rule, the power is going to multiply the coefficient, and we're going to subtract 1 from the power. So I'm going to have the derivative of y is equals to negative 3 times x raised to the power of negative 3 minus 1. Okay, I'm going to have derivative of y is equals to negative 3x raised to the power of negative 4. You can see, so the derivative of y is equals to negative 3 all over x raised to the power of 4, because x raised to the power of negative 4 can be written as 1 over x raised to the power of 4. You understand? So that is how I got this. So you can see that we still have the same answer. Hence, the solution to this question is correct. Okay, so you can see that we are done with the question. So question 2 says we should find the derivative of 5x minus 1 over x raised to the power of 3 using the first principle. We are going to do that in our next class, okay? And you can access the an hours plus video on this concept. You understand how to find the derivative of a function using the first principle. There, you will see multiple questions that you can use to practice, okay? Join our membership program to access those videos, okay? So that